So I realized on my factoring playlist that I don't have a single video that uses a negative in this position here, in the third. Oops, pardon me, I'm using a new pen and I accidentally pressed a button. Alright, so this video is going to explain how to factor a trinomial with a greater than 1, but with a negative in the third position. Okay, so let me go ahead and recap, kind of like the other video did, the steps that I'm going to go through mentally just to work through the factoring. The directions do say to factor. Now, to factor something means you're going to turn it into something times something, right? And there may be more than just two things. Maybe there's 3 factors, but if I say factor 15, you're going to have 3 and 5 or whatever. So anyway, to factor means to put it into something times something. And so I'm looking for a greatest common factor. That's my very first kind of factoring to always check. So what I'm going to look and see if the numbers, the coefficients, or the constant here in each of the terms have a common factor. Well, because there's not a number that goes into 2, 7, and 15 all evenly, then there's not a common factor in terms of numbers. But let's take a look at the variables. So there's a x squared, there's an x, but there's no x here, and so I don't have a variable that's a common factor. So basically I'm saying there is no common factor for this trinomial, these 3 terms. Because there's no GCF, or greatest common factor, then I'm going to notice the variables with their exponents. So I'm going to just notice that's an x squared, that's an x, and you notice this doesn't have an x. Well, technically it does have an x. It's really x to the 0 power. But when we have this setup where there's an x squared, there's an x, and then there's no x, or whatever variable you happen to be using, then many times it's going to factor like this. Okay, so that's where we're headed, and let's take a look. If you've watched the previous video, hopefully, and so let's take a look at the steps that we need to go through here. First thing that I'm going to do is I'm going to expand to give myself more room. So I'm going to turn this trinomial into a polynomial with 4 terms, and I'm going to split the middle term in order to do that. Now, you remember what we need to do to get the middle term is we're going to multiply. We're going to multiply the first and the last numbers together. Don't worry about the negative, just multiply the numbers. So I'm going to have a 30, and I'm now going to factor it. So I have a 30, and I'm going to go 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. Now, if I keep going, I'll go 6 and 5, but then that's just repeating the numbers in reverse order, and I don't need to do that. So, in the last video, you noticed that we looked to these to see what would add to the middle number. But because this is a negative, the last one's a negative, think if it's a minus, then we're going to minus. In other words, we're going to subtract to the middle number. In other words, what 2 factors will subtract to the middle number? So you're going to ask that. Well, the only way to get a 7 by subtracting any of these is the 3 and the 10. Okay, so we found the 2 numbers that will subtract to a 7. Now, we need it to be a negative 7. So what are we going to do? Well, of course, if I can get this to write for me, I'm going to write a negative 10x, and I'm going to write a positive 3x. Now, let's just make sure. Look at the green ones. Does a negative 10x and a positive 3x give me negative 7x? Yes, it does. Okay, so this is correct. Now I'm going to move on. At this point, I have 4-term polynomial, and I'm going to factor by grouping and see if I can. So let's go ahead. I'll adjust my color a little bit. So the first thing I'm going to do is take this first group, and I'm going to pull out the GCF. I'm going to factor it. The first way I'm supposed to factor is with GCF. So I'm going to pull out, looks like a 2 can come out, and an x. When I factor out a 2 and an x, what is remaining? Let's see. That's going to be an x, and that's going to be a 5. Let's double check. Does 2x times x give me 2x squared? Yes, it does. Oops, sorry. Again, I'm learning this new Wacom, I don't know how to say them, but pen. Does 2x times negative 5, does that give me negative 10x? Yes, it does. Great. I'm going to copy the plus, just copy it. Okay? And then I'm going to change my colors, and I'm going to take these two, all right, and I'm going to factor out the GCF there. Let's see. I'm going to pull out, it looks like a 3. Okay, here we go. I'm going to go, that's going to be an x. Looks like that's going to be a minus and a 5, but let's make sure. So, does 3 times x give me my 3x? Absolutely. And of course, the positive does work because we put it there. Does 3 times negative 5 give me my negative 15? Yes, it does. All right, now let's just try to do this just like I did the last video, and that's this. These two expressions are really two terms. If I put green on each of them, then you can see that the dark green lines identify two terms, the red term and the blue term. However, let me see if I can get me a little highlighter here. This right here is a common factor. That's a common factor. I'm going to pull the common factor to the front. If I can find a black. I'm going to pull the common factor to the front. And I'm going to look to see what is remaining. Well, what's remaining is this. The 2x plus 3. Isn't that easy? And that's it. Now, let's double check and make sure that it multiplies to that. Let's go ahead and check. Sorry. Okay, so x times x, 2x is 2x squared. X times 3 is 3x. Negative 5 times 2x is negative 10x. And negative 5 times 3 is negative 15. And again, let me try to squeeze it in here. 2x squared minus 7x minus 15. And that indeed does give us the correct thing. So what is my answer then? My answer is this right here. Here's my answer. That is factored. What's one of the factors? X minus 5. What's the other factor? 2x plus 3. Okay? Now, I'm going to go do this same problem again, but I'm going to write it where the 10x and the 3x are reversed and show you how that would adjust. It would still give you the same answer. So look at the next video to see how that would change it up in terms of how we write the signs. But anyway, we'll still have the same answer. You can't mess this up. Thanks for watching.